This last part of our chapter, section 4.3, talks about some cautions that we have to be careful of, some things we have to take in consideration, and we have to limit how we use the results from some of our studies based on the type of study, whether it's an observational study or whether it's an experiment. All right, so this slide kind of breaks down our study, and we can put it into 4 different categories. So this kind of a two-way table. So on the top, it says we're individuals randomly assigned to treatment groups. In other words, is this a randomized experiment? Okay, so random assignment of treatments or random assignment of people into treatment groups. And then on the left, it's asking, were individuals randomly selected for this study? Okay, so the best and ideal place to be is in that top left corner. So we would answer yes to both those questions. So yes, it was a randomized experiment. And yes, the people were randomly chosen for the study. Now, the problem is if this was, I say people, almost never can we do this, right? With people anyway. If I'm, doing experiments on, I don't know, lab rats, or doing some kind of experiment on a piece of machinery that I just produced, something like that, I can randomly select from the population. But with people, I'm never able to randomly select people from the population and then say, oh, you've been selected, you're going to be part of the study. So you have to really rely on volunteers for a study. So this is an ideal situation, but we're never quite there. So let's talk about the yes in both cases. So when you randomly assign people to treatment groups or run an experimental study, then you can show cause and effect. And that's a good thing. You want to be able to show that the change in the explanatory variable is what caused the response that we saw, the difference in the two treatment groups, right? Less headaches with the new medicine, whatever, right? So it's only in randomized experiments can we show causation. Okay, and then now inference back to the population, that's where the left-hand side comes in. This is if we randomly selected people from the population, then we can infer back to the population. Okay, so if we were, yes, able to randomly select and we were randomly assigning them, so in other words, randomly selected and randomly assigned to treatment groups, then we can infer to the entire population and show a cause and effect. All right, more often than not, we are in, say, this group where, yes, we ran a randomized experiment. People were randomly assigned to treatment groups, but no, they weren't randomly selected. So we can show cause and effect. The change in the explanatory variable between the two treatment groups is what caused the change in response between the two treatment groups. Definitely show cause and effect. However, we can't then infer back to the population the results of the study. So we can't say this same thing is going to happen to anyone in the population because we didn't randomly select those people from the population. So we say things like we can show a cause and effect in groups similar to those that were in this experiment. But we can't really say in the entire population because we didn't randomly select from the population. Okay, and so then the other place that we often are is here. And this means, no, we did not randomly assign them to treatment groups. In other words, we did not run an experiment. And instead, we did randomly select them for this study. So we can make inferences about this, but we can't show cause and effect. We can say people who tend to drink more than 3 cups of coffee a day tend to have higher IQs. But we can't show, and we can say that about the entire population if we sampled from that population. But we can't say that the increased coffee consumption causes you to have a bigger IQ, right? So we can't really say that. We can't show cause and effect because we didn't run an experiment. So, ideally we'd like to be in the green box, but almost always we're operating in one of these two yellow boxes. The bottom left one is an experiment, but the people were not randomly selected for the experiment. They were just randomly assigned to treatment groups after they volunteered. And then the top right yellow box is you did not run an experiment. You simply selected people and did an observational study. Okay. And then the last group is here, and this is not where you want to be. You didn't run an experiment. You didn't randomly select people. Nothing good comes out of this. You cannot infer to the whole population, nor can you show cause and effect. All right, well-designed experiment randomly assigns individuals to treatment groups. However, most of the selected experimental units, right? We don't select them from random from the population when we're doing an experiment. We just don't do that because you can't. I mean, especially if it's people, we can't randomly select members of the population and then expect that they're going to participate in an experiment. You have to ask for volunteers, basically. Okay, so we can show cause and effect in a group similar to those that partook in the study, but you can't infer back to the entire population. And then for observational studies, you can't assign them to treatment groups, right? Because we don't in an observational study. Since we didn't assign them to treatment groups, we didn't impose any treatments, and we cannot show any cause and effect. Okay, so well-designed experiment tells us that the changes in the explanatory variable cause the response change that we saw in the two treatment groups. Excuse me. But there are some times when an experiment just cannot be run because it's either not practical or just unethical. So some examples of that. Does texting, if we wanted to investigate, does texting while driving increase the risk of having an accident? Well, we can't send people out with their phones in their cars and say, okay, text while you're driving and let's see if you have an accident, right? We can't do that. Things like, does going to church regularly help people live longer? So being part of some kind of religious organization, does that make your longevity, that improves your longevity? So like that, what would that look like? That would mean one group would be randomly assigned to a group where a treatment where they would not go to church, and the other people would be assigned. So it's not practical. You can't make some people go to church and some other people not go to church. It just wouldn't work. So you're restricted there to doing an observational study, right? You can say things like, oh, people who tend to go to church tend to live longer, but you can't say that it's the church that's causing people to live longer because you can't do it as an experiment. And then the last one is that smoking cigarettes causes lung cancer. And this is what the cigarette tobacco companies were saying for years. Oh, there's no proof that smoking causes cancer, right? People who are unhealthy tend to be smokers, right? So, but it's not that the smoking is causing it, right? There was no cause and effect. And they were technically correct because there was no proof that this is true, because in order to show that proof, we would have to run an experiment, and that would be unethical. You would assign one group to randomly smoke cigarettes and the other randomly assign them to not smoke cigarettes, and then wait 10 years, wait 20 years and see the survival rate in the two groups. All right, so how do we establish causation? Because obviously there's going to be some situations where you cannot. So in other words, everybody accepts the fact now that smoking causes cancer, lung cancer, and other kinds of cancers as well. And so how do we come to that conclusion when you cannot run an experiment which would show causation? All right. So we have to follow some criteria for establishing causation, and one is the association strong? So is there a strong correlation between the two variables, the number of cigarettes you smoke every day, and the occurrence of cancer? Is it consistent, right? If if some people smoke and they die, but the other half of the people don't, then that would be inconsistent. So there has to show the association has to be consistent. And then, larger values. So in other words, this group of people tend to only smoke one cigarette a day. What's the death rate there in that group, due to lung cancer? And this group smokes a pack a day. A pack of cigarettes is 20 cigarettes. So if you smoke 20 cigarettes a day, you would expect that group of people who say they smoke 20 cigarettes to have an occurrence of lung cancer that's much higher than the group where only one. So a larger explanatory variable causes a stronger response. So the more you smoke, the more likely you are to be to have lung cancer. All right, and then one has to precede the other in time, right? So I'm smoking for a month, I get lung cancer. That's probably not causing the lung cancer, right? But I've smoked for 20 years, I smoked for 30 years, whatever, it precedes it in time. And then also just, it's got to be plausible. All right. So that's how, over the years, we have established the fact that, yes, smoking causes cancer, even though we can't run a comparative experiment, forcing some people to smoke and some people not to smoke, right? Can't do that. That would be unethical. All right, so the next thing we want to talk about is the ethics in experiments, like, running experiments ethically. And so this is an image of an experiment that was from 1951. Now, so 1951 was right after World War II. And so if you remember, towards the end of World War II, when the Allies were liberating Europe, that's when we were aware of the Holocaust and the fact that German soldiers were killing millions and millions of Jews. And so I think a lot of people couldn't understand that, and so psychologists and people who ran studies trying to, emulate that situation. So I think that's where this experiment that we're going to talk about sort of comes from. So it's a psychologist called Milgram, and he ran this experiment where they asked for volunteers to come and they said they were doing a study on memory. And so there were two people, and one was assigned the teacher and one was assigned the learner. And so the teacher would read a number of words, and then the learner, who is in another room, they were communicating audibly with each other. And so that person would give the response, and then if the response was wrong, then the teacher in the other room was in front of a device, and you'll see that in a minute, and they would shock them. They would give them a shock. And so this person you see here, they're strapping their arm to this electronic device that would give them a shock. So this person sitting down with the tie on and suspenders, this man, would be the learner. Okay. And then the other person is sitting in front of this device, pretty scary looking device, and you can see there's little switches as you go across. And as you go across, each time the learner answers incorrectly, they throw another switch, which shocks the person, and in increasing voltage as you go across. And so this study was, when they asked for volunteers, they told the people that this was a study on negative reinforcement with learning, right? How that could happen. But in reality, this was not a study about that at all. And this person who was the learner in the previous picture, that person was actually an actor and was in on it. And so really what they were testing is how far would the learner, the teacher, the person who was administering the test and shocking the person, how far would they be willing to go to hurt another person when they were just told to do so? And so this is the person sitting in front of the machine. This would be the teacher. This is the one person that isn't in on it. He didn't know that he was the one who was really the subject of the study, not the learner. And so then he would sit in front of this machine, and give a test to the person, and then when they got it wrong, they would have to shock them, and with each wrong answer, the voltage would increase. They would go to the next switch, and they would increase the voltage. So the video that you're going to see here is from probably like the 60s, and it's talking about this experiment. Oh, and that's sorry, this is the psychologist who ran this experiment, Dr. Milgram.
A decade earlier, psychologist Stanley Milgram had also looked at how we respond to authority. In order to understand how people were induced to obey unjust regimes and participate in atrocities such as the Holocaust, he set up an experiment. Volunteers were told they were taking part in scientific research to improve memory.
Would you open those and tell me which of you is which, please? Teacher. Learn. Teacher.
Separated by a screen, the teacher would ask the learner questions in a word game and administer an electric shock when the answer was incorrect. He was told to increase the voltage with each wrong answer.
Cloud. Horse. Rock. House. Answer. Wrong. 150 volts. Answer. Horse.
Experiment, that's all. Get me out of here. Get me out of here, please.
Continue, please. Go right ahead.
I refuse to go on. Let me out.
He refuses to go on. The experiment requires you continue, teacher. Please continue.
Participants didn't know that the learner was really an actor and the so-called shocks harmless.
You're gonna get a shock. 180 volts.
Ow! I can't stand the pain. Let me out of here.
Can't stand it. I'm not gonna kill that man, eh? I mean, who's gonna take the responsibility if anything happens to that gentleman? I'm responsible for anything that happens here. Continue, please. All right, next one. Slow. Walk, dance, truck, music.
Two-thirds of volunteers were prepared to administer a potentially fatal electric shock when encouraged to do so by what they perceived as a legitimate authority figure. In this case, a man in a white coat.
375 volts. I think something's happened to that fellow in there. I don't get no answer. He was hollering for less voltage. Can't you check in and see if he's all right, please?
Milgram's findings horrified America. They showed that decent American citizens were as capable of committing acts against their conscience as the Germans had been under the Nazis.
Okay, so the reason that we talk about this experiment is because it was sort of revolutionary in that it really helped define the rules for running experiments. So you can kind of imagine the, sorry, let me...
A decade earlier, psychologists
you can imagine the psychological harm that being a subject in this study would have caused, right? And what was worse is they never debriefed the people afterwards, right? So they didn't tell them at the end. Now you don't have to. You wouldn't, if you're running an experiment and it's not wrong to tell them that you're studying one thing and then be actually looking for something else, because if you tell people what you're looking for, then they'll act differently, right? So if they had told them that this is really this is all fake and that this really isn't, then people would be switching the switches without any consequences and not worrying about it. So, but you have to make sure that you're not causing psychological harm, right? So the harm that you think you're actually possibly killing someone, right, or giving them a lethal shock, is dangerous, right? And you want to, when you're finished with an experiment, you want to debrief the person. It's like, oh, well, we told you that we were having you come in and study this, but in reality, we were really studying this, right? So you want to sort of debrief them, but also not do anything that's psychologically harmful. So this experiment and its results really changed what we do and how we run experiments. They did a lot of things, really bad things, I guess, right? I mean, ultimately, didn't follow some basic rules, and so we kind of came up with some more basic rules. And so one of them, and so some of you might have to run experiments of some sort if you go and do a doctorate or even a master's degree. Sometimes you have to do a dissertation or a master's thesis if you're getting a master's degree. And sometimes this involves working with students or doing an experiment. And so you have to get institutional review. So like if you're working at if you're studying at a university and you want to run as part of your dissertation a particular study, you have to have there's people at the university that review any experiment that's going to be run or any study that's going to be done to make sure that there's no harm going to be done to any of the subjects, right? So there's these institutional review boards that have to okay what it is you're going to do. And you also have to get informed consent. Now that doesn't necessarily mean you're going to tell everybody up front what this study is really about, but you can't cause harm to anyone, right? And then also any results should be confidential, especially if you're doing something in an educational environment. You can't release the results of your study. You would have to, instead of using names, you would have to have number your subjects so that you're not revealing any information about your subjects to the public. All right, so this is your homework for this last section in chapter 4.